Well, what we'll do then, could I get everybody to shift the desks that way? In fact, let's just do these 3 rows, shift them clear to the wall, and shift these 3 desks, 3 rows clear to the wall, so he opens up this middle part here. The harder it is to get up effectively. Thank you. All right, what I need now is I need everybody who is a Utah native. Does that, you know what that means?
Born in Utah?
Yeah, native. Native means you're born in Utah. In fact, nativity means what? Nativity scene, the birth scene, right? Okay, native. So if you were born in Utah, I'd like you to come get in this circle. If you've got more than 6 siblings, I'd like you to get in this circle. Figure it out.
Exactly 6. 2.
We still have quite a few Utah natives.
And then I'm in the middle.
Yeah, I'm just going to stick a foot here.
Yeah.
This is more than 6.
Yeah, this is more than 6.
Okay, so we have 4 people that have a foot at least in. We need bigger strings, right?
Yes. That'd be grand.
Okay. All right. Samantha, raise your hand. What can you tell me about Samantha?
She has more than 6 siblings.
She has more than 6 siblings. That's all you can tell me?
But she does not live in Utah.
She's
not native in Utah.
She was not born in Utah. So we know 2 things about her, right? Based on her Rebecca, raise your hand. So, tell me 2 things about her.
Has less than 6 and born in Utah.
She was born in Utah. She says, I only lived there a short time. Are you embarrassed about that?
No. I consider myself from Utah, even though I've lived most of my life in Texas.
Oh. Okay, so we know 2 things about her. And Stephanie, what 2 things can we say about her?
More than 6 siblings. She was born in Utah.
She has more than 6 siblings, and she was born in Utah. Okay, Brianna, raise your hand. What can we say about her?
Neither.
We can say 2 things about her as well, right? Does that make sense? Okay. All right, you guys can all sit down. Let's give you some notation, some symbolic notation to talk about these ideas. If we let the entire classroom be what we're going to call the universal set, and we had, we're going to call it n, is equal to students born in Utah. I'm just calling it N for natives of Utah. And then if we let another set be, we'll call it set S. S is equal to the students with greater than 6 siblings. Okay? We had 4 students in here, and the way we represent that is we'll say in intersect S. This upside down U with no tail means intersect, and it refers to what they have in common. Intersection is not just a math word. If we can think about intersection in other areas besides math, it will help us understand what it means in math. Somebody think of a word intersection. Yes?
2 streets. Like
An intersection of 2 streets. So if I have this street going this way and this street going this way, where is their intersection? It's the place they have in common. So this is not a math word. This is an English word, but we're using it now specifically for a math term. Okay? What would this be? It would be what? Either. What do you mean by either?
That they can be from Utah or they can be.
So this would be the students who are born in Utah or have more than 6 siblings, right? Notice she said either, and she used the word or, and then I emphasized it again. This is an or. Over here we'd say, in fact, let's just do it. Stand up if you're a native of Utah and you have more than 6 siblings. You better have 4 people, because that's the... Notice, when you say and, it has to belong, you have to belong to both in order to be in the intersection, right? So this is, when you see an intersection, we're talking and. We okay? All right, so there's some symbolism. Now, Brianna over here was what we would call she's part of a set called the complement of n. What would that mean?
She doesn't have 6 siblings?
N.
Oh, she doesn't. I don't know. I'm just guessing.
Yeah, it's all the people that aren't natives of Utah. Okay? That word complement, that's the symbol we use for the set. We just put a bar over the set, meaning the complement of that set. Notice I didn't spell it with an I. I spelled it with an E. What do I mean? There is another word, complement, that has an I. Which I? Which one of the E's is an I? The first one. This one right here, right? When you came to BYU, Idaho, your mother may have said, I really hope you find a young man that compliments you.
My mother would never say something like that.
Well, she ought to. She doesn't mean Find a young man that says, "Oh, you're sure beautiful today." What does she mean?
One that goes well with you, brings out the best in you.
I'm not going to go quite with you. Who else wants to?
That like has what you don't have.
Yeah.
That's those and those things.
Like what? What would we mean? What would you want to have that, or what would you want your husband to have that maybe you don't have?
Well, for me, I'm not as social as my mom, and so I need to kind of find a husband that will be as social as my mom. So we kind of balance each other out.
Okay. What other aspects?
Someone that's smart.
Oh boy! Cut yourself. Maybe in we'll go off of that. Certain areas. There we go. There we go. Okay. I have to tell you, when we got married, my wife had never balanced. She had never reconciled her checking account once.
Oh my God.
I said, "How do you know what you?" "Oh, I just kind of keep a total going, and in my check register." And I said, "Well, how do you know whether I just trust the bank to know there's no problems." And anyhow, she does all of our books, by the way, now, so we've gotten her past that. But if you can't discipline kids, you better find somebody that can. If you can't keep a checkbook, you better find somebody that can, right? That's what we mean by complement. So, if N is here, everything inside here, the complement of N would be everything outside, including here. This is the complement of N as well. So the complement of N is outside of N. Does that make sense? So whatever N doesn't bring to the marriage, complement of N will have it, right? Does that make sense? Again, it's not a math word. It's an English word. And we need to be able to remember what it means in English, and that'll help us remember what it means in math. Okay. All right. Let's let this circle right here be the number of, or all the students whose number of siblings in your family is greater than 15. Everybody just come out and...
Oh, are we counting just blood or more?
Yeah, you got one of those,
I have 12 blood. And
yours, mine, and ours.
4 step plus an additional 3.
And then there's the foster ones.
No foster kids. No foster kids.
Let's just say blood to try and achieve what I'm after. So here we've got a set with what? Nothing in it. Okay, so we call that, there's the symbol. Everybody know what that's called? The empty set. Okay? The empty set. In fact, let's use a word that we're going to try and teach you in Unit 2, but you need to use it in one of your reflection questions, and that is, what if, let's do this, all the students who were born in Rhode Island, do we have any of those in here? And well, let's see what would the best way to do this would be. Let's do this. Let's have every student whose address is, whose permanent address. That means where you get your mail both on and off, well, off track particularly, off track. Where you get your, where do you spend your time? I want everybody whose permanent address has an Idaho zip code in it, get in this circle. Permanent address of Idaho in this circle. I want everybody whose permanent address is Rexburg in this circle. Anybody want to react to this?
Well, for starters, the three in the center are not standing correctly.
The three in the center. What do you mean?
The Rexburg circle is the other side, so you need 1 foot in there and 1 foot on the other side.
Technically, the Rexburg circle should be inside of the Idaho circle.
Yes?
Yeah.
Is there anybody whose zip code is Rexburg that doesn't have an Idaho zip code?
No.
Does everybody see what I'm saying? So, okay. Thank you. You can all sit down. If we let I be the set of students with permanent Idaho address, okay, and R be the set of students with a permanent Rexburg, Idaho address, Rexburg address, our diagram would look like this, correct?
Yes.
There is nothing that's in R that is not also in I, right? Does anybody know Rexburg's zip code? 83440, unless you're on campus.
And it's 460.
Then it's 460. And so we could maybe put one out here if you're Rexburg, you could, right? Anybody in the dorms? So that's 60, right?
Yeah.
So they're actually out here. We call them the dorms, right?
Mr. Piper, wouldn't it be inside the Rexburg circle? Because
Would
it's
it?
Also...
If with permanent Rexburg zip, that would be 83440, right? And this one's going to be 83460. Would there be an overlap here?
No, there wouldn't.
Ever would there be?
No, because you can't have two permanent addresses.
You cannot have two permanent addresses, especially with two different zips, right? Okay. So
But the thing is, what she's saying that technically the school would be in Rexburg.
it would be in the city of Rexburg, but it wouldn't be in the zip code of Rexburg. Okay. So here's what we say. If we take D and intersect it with R, what do we get? Thought I may have heard it. A little louder. The empty set. Right? We get a set. This intersection has nothing in it. Never will have anything in it, right? When you have a situation like this, we call these disjoint sets. So what's a disjoint set? It's two sets whose intersection is empty. Now those of you who've been working on the reflection questions, have we seen something like this? In our number theory unit, if we were to take the whole numbers and divide them into sets that are disjoint, what might that be? Here's our whole numbers. Anybody know anything about how could we divide those up into different sets? Okay, should I overlap them? This is prime. Should I overlap? No? Are there any composites that are prime or prime that are composites? So we would say those are disjoint sets, right? That's one way we could do it. By the way, where's one? Out here, right? If these are the two subsets. By the way, let's get some, we would say R is a subset of I. R is a subset of I. It fits inside of I. Everything that's in R is also in I, right? We would say D is a subset of I. Does that make sense? If you're in the dorms, your zip code from the dorms is going to be a subset of the Idaho zip codes, right? We could say a composite number is a subset of the whole numbers, right? So this here is a subset of. There's one more symbol. Let's just give you an example here. Let's say that set A is the set of 1, 2, 3. Set B is the set of 1, 2, 3, 4. We can say A is a subset of B, can't we? We can also say A is a proper subset of B. Why? Because if this is B, A is in here, 1 belongs here, 2 belongs here, 3 belongs here, but 4 belongs here. When you have a proper subset, which is without the line, what that means is that there's a number outside of, let's get the outside of set A. I can find it in B, but I can't find it in A. Whereas, let's do this one here. Let's let C be 1, 2, 3, 4. We could say that C is a subset of B, but we can't say C is a proper subset. Here's why. Because everything that C's got, B's also got. Oops, I'm doing the wrong one. No, yeah. Everything that C's got, B also has. It's kind of like the greater than and the greater than or equal to signs. See that little equal to? These can be equal, right? But if I use this one, they never can. That means there's something out here in the bigger set that I can't find in the smaller one. Does that make sense? Wherever I say this, I can always say that, but not vice versa. Does that make sense? This one is more inclusive. So this is a proper subset, and it means there's something in the bigger set that you can't find on the inside one. Whereas this one, it could be proper or improper, or not improper. It could be a proper subset or not a proper subset, but it might be the very same set. Okay? So this is true and this is true, and this is true, but this is not true because they're the same. And to be proper subset, there'd have to be one in B that I couldn't find in C. Does that make sense? Okay. Let's see if I've given you all the symbols and all the I think we have. All right, you got a blank piece of paper? We're going to just try this in the last 5 minutes and see what we can come up with. I would like you to make me a Venn diagram of the following sets. U is all church members.
Which church? Ours?
Yeah. Which church? Let's assume it's the LDS church.
Okay.
Let's let G be all or any of the general authorities. Okay? A is an ordained apostle. F is a member of the first presidency. S, let it be the set of the ordained 70. And let's let Q be a member of the quorum of the 12. So, you may want to do disjoint sets. Everybody get that word? You may want to do subsets of how would this look if you were to make a Venn diagram of this. You can kill it now.